Matrices is the plural version of the word matrix. A matrix is basically just a set of numbers that have brackets around it. So this matrix, let's call this matrix A, is a 2 by 2 matrix, and it has the following numbers: 1, 4, 6, 7. So notice, when I said this is matrix A, this matrix name is a capital letter. Another thing you should have noticed is how I told you this was the size was a 2 by 2. And notice when I read you the numbers inside, I read from left to right. And then I went to the next row, left to right. So basically, it's just like reading a book. When you read these numbers out loud, it's left to right, the next line left to right, next line left to right, and so on. Now let's take a look at matrix B. Matrix B is a 2 by 3 matrix. That's the size of this thing. Now how do I determine size? Size is always by row by column. So the number of rows, we have 2 rows and 3 columns. So let's not forget the word column means something that's standing up, so that's why it's in the vertical direction. Let's think of a couple ways to remind ourselves that the order is row by column. So R by C. So like RC Cola, Roman Catholic, like those are, just try to remember it's always row by column. Some people get it mixed up and we don't want to do that. Okay, so I'm just going to read this out loud. This is a 2 by 3 matrix that has the elements 1, 2, 3, 4, 5, 6. Now just as practice, I'm going to give you a matrix called C. And I'm just going to verbally say this out loud, and you should fill in what matrix C looks like. So matrix C is a 1 by 3 matrix. It has the elements 4, pi, and 0. So this is going to be a 1 by 3 matrix, and what you should have gotten was 4, pi, and 0. So when someone says a matrix to you, like describes a matrix to you, you should be able to just fill it in according to what they've said, using the size and the elements that they've listed out. So let's look at this example. I've given you a new matrix A and still the same matrix B. Now let's say I want to add these two matrices together. Adding matrices and subtracting matrices is really simple. But the only thing that you have to consider is the size of these things. So matrix A is a 2 by 3, but it has 2 rows and 3 columns. Matrix B has 2 rows and 3 columns. So, like I said, you have to just consider their sizes. Now, because they're the same size, that means that my solution matrix, the A plus B, is going to be also the same size, 2 by 3. Now this is fairly easy. All we do is just add by components. So we just add like 1 plus 1 is 2. 0 plus 2 is 2. 1 plus 3 is 4. 1 plus 4 is 5. 0 plus 5 is 5. 1 plus 6 is 7. So notice you just add it by like the same exact position. Now let's say I asked you for A minus B. Well, A minus B is the same exact thing. You just take each element and subtract each part. So here we get 1 minus 1, which is 0. 0 minus 2, which gives us negative 2. 1 minus 3 is negative 2. 1 minus 4, negative 3. 0 minus 5, negative 5. 1 minus 6, negative 5. So notice this is also supposed to be a 2 by 3 matrix. So when we add and subtract matrices, these matrices need to be the same size. So for example, if I ask you to add these two matrices, clearly you cannot because this is a 2 by 2 and this is a 2 by 3. And also notice, like, how would I add it if I'm doing it by component? Like, what does this 4 add up to? Like what do I add the 4 to? What do I add this to? So If you have two different sizes, this is not doable, so there are no solutions. But one thing that is doable for matrices that are not the same size, it could be doable, is we can take the product. So A times B. So the product is a little bit more tricky. So the first thing you want to check when you are multiplying matrices. So because I'm doing the order of A times B, you have to make sure that the two middle numbers are the same thing. If they're the same, that means it's doable. Then these outside numbers tell us what's going to be the size of my solution matrix. So for instance, this will be a 2 by 3 matrix, meaning I will have 2 rows, 3 columns. Now before we actually multiply these things, let me describe to you like something in a second. You see this element with 1 in it? Well, we would say this is in position 1, row 1, column 1. This one would be in row 1, column 3. This one would be in row 2, column 3. So knowing where these elements are will help us figure out like how to figure out these 6 elements here. Okay. So this first one right here is in row 1, column 1. So what I'm going to do is multiply row 1 by column 1 here. So using like the dot product, okay, I'm going to write it on the side. We would take 4 times 1, this 4 times this 1, plus 1 times 4. So that would give us 8. So this element is 8. Now this element right here is in row 1, column 2. So I'm going to take row 1 here, multiply by column 2 here. So that gives me 4 times 2 plus 1 times 5, which gives us 13. So that element is 13. So let me do that again. So that was 1 times 2 plus 1 times 5. Okay, this element right here is in row 1, column 3. So I'm going to multiply the first row with column 3. So that would be 4 times 3 plus 1 times 6, which gives us 18. So let me do that again. So that was 4 times 3 plus 1 times 6. Okay, now this bottom left-hand one, that's in position 2, 1. Second row, first column. So second row multiplied by the first column. That'll give us 0 times 1 plus 2 times 4, which gives us 8. Once again, it's 0 times 1 plus 2 times 4. This next element is in row 2, column 2. So I'm going to multiply row 2 by column 2. So that's going to be 0 times 2 plus 2 times 5, which gives us 10. So once again, it's 0 times 2 plus 2 times 5. And this last element is in row 2, column 3. So I'm going to take the second row, multiply by column 3. So 0 times 3 plus 2 times 6 gives us 12. So once again, 0 times 3 plus 2 times 6. So there we have our solution for A times B. Now let's say I want to find B times A. But before we do that, we should probably check the sizes. So I know B is 2 times 3 and A is a 2 by 2 matrix. If you look, the two middle numbers do not match up. So therefore, there is no solution for this matrix. So remember, the middle numbers have to be the same for you to be able to multiply two matrices. And the outside number is the size of the solution. Another example, if we have a scalar in the front, all we do is just distribute that to everything inside, and still is the same size, but everything is multiplied by 4.